All right. Hello, everyone. My name is Suzanne Millman. I'm delighted to be chairing this session, and I've been really enjoying the talks so far and the discussions coming out of that. So I hope you also enjoy the session we have coming ahead of us. Um, our first presenter is going to be Samantha Vitek and Leone Jacobs. They're going to be discussing flock characteristics associated with broiler chicken welfare issues during the pre-slaughter and slaughter phases.
Thank you for the introduction. My name is Samantha Vitek, and today I'll be presenting broiler chicken flock characteristics associated with welfare issues prior and during slaughter in the United States. About 9.5 billion broilers were processed in the United States in 2024. Here, the graph shows you on a logarithmic scale the number of animals slaughtered commercially in 2022. Cattle were around 34 million, pigs around 125 million, turkeys around 208 million, and then our broiler chickens at almost 10 billion. Injuries such as bruises and fractures, dead on arrivals, shackling ineffectiveness, and conscious birds post-cut are all an animal welfare concern and also an economic loss to the industry. Here, if we look at the actual difference in animal numbers, it looks more like this. This shows that if there are issues occurring in the industry, many animals are at risk to experience poor welfare. Multiple risk factors for these injuries have been identified in other countries. Parent flock age is one of them. There is a higher chance of wing fractures for broiler flocks with a higher production week of the parental flock. Flock size. As flock size increased, so did the dead on arrival rates. Flock mortality. As the flock mortality rate increases, so do dead on arrival rates. And then bird weight and age. For bird weight, as body weight increases, so does the dead on arrival rates and bruising rates. And then for slaughter age, the DOA increases for birds who are slaughtered at a heavier age compared to those that are slaughtered at a young age. These animal welfare indicators and risk factors are often already available and routinely collected at plants. However, this data is rarely thoroughly assessed to find statistical associations and identify solutions. The objective of this study is to explore associations between flock characteristics and broiler welfare issues prior and during slaughter. Our data represents 20 million broiler chickens from 152 United States farms, 161 transports, and 3 processing plants. For the definition of farm in the study is the number of birds dispatched from farm to factory. So this may be birds in one complex that consists of multiple farms. Here we have the flock characteristics and welfare measures that were collected during the project and the phases that they represent. These data were collected by workers at the farm and slaughterhouse, entered into Excel spreadsheets, and then uploaded into an online software. The breeder flock age was 40 weeks. The on-farm mortality rate was 5.12%. The flock size was around 124,000. Bird weight at slaughter was 2.55 kilograms. Age at slaughter was 42 days. And then for our welfare measures, we have dead on arrivals. So this is any broiler that was found dead at the time of unloading or shackling at the slaughterhouse. Wing fractures, these were assessed using the American Association of Avian Pathologists guidelines. A wing fracture was recorded if there was a dislocated or broken wing observed prior to feather removal. And then leg bruising was also assessed using the American Association of Avian Pathologists guidelines. It was recorded when the bruise was greater than 2.5 centimeters in diameter, about the size of a quarter, after scalding and feather removal, but before chilling. Shackling ineffectiveness was recorded when there was an ineffective shackle, so the broilers were shackled by one leg, there was a previous paw in the shackle, or they were cross-hung. Conscious birds post-cut were recorded when signs of sensibility were present, after the automatic knife split. We did Pearson's correlations in Jump Pro 16. This is an exploratory study with preliminary data, so only simple statistical analyses were performed. Our mean dead on arrival rate was 0.26%. Here on the graph, on the x-axis, we have flock ID, and on the y-axis, we have DOA in percentage. The orange line represents the mean dead on arrival percentage, and this was not correlated with other flock characteristics. The mean prevalence of wing fractures was 5.51%. Here on the graph, we have breeder age in weeks on the x-axis and wing fracture percentage on the y-axis. For the rest of this presentation, all flock characteristics will be on the x-axis and all welfare measures will be on the y-axis. There was a positive correlation between breeder flock age and proportion of birds with wing fractures. This means that flocks with an older breeder age were found to have high proportions of wing fractures. There was a positive correlation between flock size and proportion of birds with wing fractures. This means that larger flocks were found to have high proportions of birds with wing fractures. There was a positive correlation between on-farm mortality and proportion of birds with wing fractures. This means that flocks with high on-farm mortality rates were found to have high proportions of birds with wing fractures. Here we have two graphs. The first graph shows live weight at slaughter and wing fractures, and then the second graph shows age at slaughter and wing fractures. There was a strong positive correlation between live weight at slaughter and wing fractures, as well as age at slaughter and wing fractures. This means that heavier bird flocks and flocks with older birds were found to have high proportions of wing fractures. The mean prevalence of leg bruising was 1.53%. There was a positive correlation between flock size and proportion of birds with bruising on legs, which means that larger flocks were found to have high proportions of birds with bruising on legs. There was a negative correlation between breeder flock age and proportion of birds with bruising on legs. This means that flocks from a younger breeder age were found to have high proportions of birds with bruising on legs. There was a positive correlation between on-farm mortality and proportion of birds with bruising on legs, which means that flocks with high on-farm mortality rates were found to have high proportion of birds with bruising on legs. There was a positive correlation between live weight and bruised legs, as well as age at slaughter and bruised legs. This means that heavier bird flocks and older bird flocks were found to have higher proportions of leg bruising. The mean prevalence of shackling ineffectiveness was 0.94%. Remember that an ineffective shackle is a bird that are being shackled by one leg, another body part, paws from a previous bird are present, or they are cross-hung. There was a positive correlation between live weight and shackling ineffectiveness, as well as age at slaughter and shackling ineffectiveness. This means that heavier bird flocks and flocks with older birds were found to have higher proportions of ineffective shackles. The mean prevalence of conscious birds post-cut was 1.42%. There was a negative correlation between live weight at slaughter and conscious birds post-cut, as well as age at slaughter and conscious birds post-cut. This means that lighter bird flocks and flocks with younger birds were found to have higher proportions of birds conscious post-cut. The mean prevalence of wing fractures in this study was 5.51%. This is deemed high according to the National Chicken Council guidelines. The National Chicken Council is a national trade association that represents the broiler producer processors. They recommend their guidelines to its members to assure humane treatment of broilers and to promote the production of quality products. They developed an audit to evaluate current commercial strains of broiler chickens by auditing how these birds are raised, housed, managed, and processed. There are specific thresholds for each animal welfare indicator, as well as an ongoing effort to improve conditions over time. Members who adhere to these guidelines help demonstrate that a producer is committed to high animal welfare standards, and this can help foster trust with consumers and retailers. Their guidelines state that wing fractures should be less than or equal to 4.2%, in which our data is above that. If we look at the transport level, we'd see that 44 out of 161 transports would be deemed unacceptable. And then we wanted to see how it compares to other studies. We found that in other studies, the wing fracture prevalence ranged from 1.9 to 13.9%. Leg bruising rates was 1.53%, which is deemed high according to the National Chicken Council guidelines, which states that it should be less than or equal to 0.8%. If we look at the transport level, we'd see that 55 out of 161 transports will be deemed unacceptable. And then if we compare this to other literature, it ranges from 0.1 to 1.4%, in which our rates are above that. The dead on arrival rates in the study was 0.26%, which is deemed acceptable according to the National Chicken Guidelines, which states that should be less than or equal to 0.4%. 15 out of 161 transports would be deemed unacceptable. And then in literature, DOA rates range from 0.12 to 0.46%. Shackling ineffectiveness was 0.94%, and this would be deemed acceptable according to those guidelines, which states that it should be less than or equal to 1%. 4 out of 112 transports would be deemed unacceptable. And then for conscious birds post-cut, the mean prevalence was 1.42%, which is acceptable as it is less than 2.2%. No transports will be deemed unacceptable. So here we have our flock characteristics and our animal-based measures and the phase they represent. This will show the relationship between the flock characteristics and the welfare measures. This is not a causal relationship, but an increased risk for these injuries. Here we'll have positive correlations shown in maroon and negative correlations shown in orange. So there was a positive correlation between breeder flock age and wing fractures, a negative correlation for breeder flock age and leg bruising. On-farm mortality rate was positively correlated with wing fractures and leg bruising. Flock size was positively correlated with wing fractures, leg bruising. Bird weight was positively correlated with wing fractures, leg bruising, shackling ineffectiveness, and then negatively correlated with conscious birds post-cut. Age at slaughter was positively correlated with wing fractures, leg bruising, shackling ineffectiveness, and then negatively correlated with conscious birds post-cut. So risk factors for broiler welfare include breeder flock age, on-farm mortality, flock size, live weight at slaughter, and slaughter age. Data on broiler chicken welfare are routinely collected at most processing plants, and we recommend that these data are used to improve welfare and with that, economic outcomes. These data can be used to identify risk factors, especially when the data are collected at flock level. In our study, the next steps are to increase the sample size, include other risk factors, and conduct a multivariate analysis. I'd like to thank our funder for their financial support, the project team for their contributions, and the processing plants for sharing data. Thank you.
Thank you very much, Samantha. Can you turn on your camera and microphone and we'll get to some of the questions. Nicely done. Uh, One of the questions comes from Stephen Wickens, and this is really kind of knowing that we have an international audience here. Could you clarify what you were considering to be a flock? Were those all birds kept in the same housing, or were they shipped at different times? So just maybe talk through in the systems that you were working with, what were you considering a flock?
Yes, great question. Thank you, Dr. Wickens. So a flock in this study was the birds from multiple houses, but we're still on the one farm. So they're all transported at once.
Mhm. Thank you. And then we also have a question from Berthe Nielsen, who said, were you surprised that the DOAs, the dead on arrivals, were not affected by flock characteristics, given your strong results on heavier older birds and some of those other wing fractures and some of those other outcomes?
Yes, thank you. So that was surprising because, as we've seen in literature, DOAs are associated with multitude of factors, including older ages and higher slaughter weights. With that being said, when we did correlations previously on a smaller data set, there was associations, but then when we did it on this data set, there wasn't. I believe since
Okay.
this is a preliminary study, once we increase our sample size and do the multivariate, that we will see a relationship with one of the factors at least.
Okay. Thank you. Um, and then I have a question from Dr. Bas Rosenberg. For the high percentage of wing fractures, is there a relationship with catching method? Was this automatic catching with a harvester or was it manual?
Thank you for the question. So, unfortunately, we don't have information on how these broilers were caught. We do see that in different systems, there may be higher or lower prevalences of wing fractures. So, that is information that we're hopefully going to get from the company so then we can do a multivariate to see if that would be a risk factor.
Nice. Thank you. And I have a question from Eva Reed. She says, impressive. Can you explain the negative effect on shackling ineffectiveness, but there was a positive effect on consciousness post-cut? Which could that be age or weight?
Great question. I think it may be backwards. I believe that shackling and effectiveness was positively correlated with age and weight, and then conscious birds post cut was negatively correlated with age and weight. It was interesting to see that difference, especially on the slaughter line itself. One explanation, I believe, for that could be that the automatic knife slit is not properly adjusted to the proper weight and height of the bird. So it's unfortunately not doing its job properly.
Okay. And I've got kind of a related question from Lindsay Goodale, who says, is the National Chicken Council's rate of acceptable conscious birds post-cutting, excuse me, less than 2.2% based on science? I wouldn't think that would be acceptable. And I wanted to add on to that question, you had breeder flocks. So do you think that, given that the National Chicken Council is for all broilers, do you think that that needs a separate guideline for broiler breeder birds?
Yeah, broiler breeders are completely different from the broiler chickens that we see and eat. So, yes, there should be different recommendations on guidelines for your broiler breeders. And then could you repeat the question one more time, the first one?
She was asking about that 2.2%, just sort of questioning, was
Yeah.
that seemed high, right?
Yes, that does seem very high. One thing that the National Chicken Council strives for is continuous improvement. So if we don't have any baseline set at all, there's no way we can continuously improve in the future.
Yeah, nicely done. I've got a question from Anthony Armory. Um, a really extensive study, nicely presented. There seems to be two weight groups around 2 kilos and then again about 3 to 4 kilos. Do these represent different types of birds? And I also noticed this on you had a bimodal distribution on your ages. So were some of these breeders pedigree flocks and some of them were, the production flocks, or why did you have that split out that way?
Yeah, so in the United States, our broiler production is typically divided into two sections. You have your light broilers, which are typically under 6 pounds, and then you have your heavy broilers, which are above 6 pounds. So in our data set, we do have companies who are providing both those small birds and those heavy birds. So that's why we see that huge difference in the data set. But we
Okay.
are planning on doing a separating that to see if there is any differences between weight classes.
Yeah, because there might be an interaction. Is that what you're
Mhm.
thinking? Yeah,
Yes.
nicely done. All right. Thank you very much, Samantha.
Thank you.
And our next speaker will be Kylie Thurman, who is going to be telling us about errorless learning in the laboratory, teaching rhesus macaques in brain-computer interfacing studies.
Hello, my name is Kylie Thurman. I'm the head of animal care at Neuralink, and today I'll be speaking on errorless learning in the laboratory when teaching rhesus macaques in brain-computer interfacing studies. Currently, when teaching rhesus macaques behavioral tasks to demonstrate functionality of biotech devices, typically the method of trial and error is used, in which problem solving is achieved through repeated, varied attempts until success is reached. This method was first detailed by Edward Lee Thorndike in the early 1900s, but obviously there's been a ton of research on how animals best learn since then. Even still, this method is really popular, especially in this field, despite research showing that it can cause considerable frustration. In contrast, in the science of applied behavior analysis, errorless learning is used instead to ensure the learner stays successful at every approximation. If you were learning how to play the game Pong errorlessly, the accompanying software might look like something like this video on the left. At first, you'd have a huge paddle and a stationary ball, so as long as you're moving the joystick, there's no way not to hit your target. As you gain competence, the software allows you to adjust different parameters to increase and adjust your criteria. And then once you're ready for it, you can face our friend Pager, who's mastered at the task. Most importantly, a trainer would be there to adjust the criteria forwards or backwards in response to small behavioral precursors and facial expression, indicating your level of comfort with the current approximation. There are a number of different components within errorless learning that enable learners to maintain success. There's prompting, in which assists are given directly to set the learner up for the task. Cues are used to help the learner understand under what environmental conditions they should perform previously learned behaviors. And then we can also manipulate the environment in ways that set the learner up for maximum success through the use of antecedent interventions. There have been some great studies on errorless learning in other contexts, such as this paper in which dogs displayed faster acquisition with fewer accompanying frustration behaviors when learning a visual discrimination task through the use of errorless learning. There's also a category in between these two different approaches that we've labeled as criterion-led, where the game is broken down into a series of set approximations so that animals aren't immediately asked to succeed at final criteria, but within those approximations, they do have to figure out the correct stepping stone behaviors towards success on their own. I'll give an example of each of these strategies in another language most of you are probably familiar with, the world of Mario Kart. With the trial and error strategy, you'd be completely solo and your car would just be dropped right into the middle of Rainbow Road the very first time you play. Imagine you're just a kid, you've never touched a real steering wheel in your life, no friends to follow through the course, no bumpers to keep you from falling into the abyss of Mario Doom. It's just you probably driving backwards in 12th place on an upside down rainbow, slipping on your own banana peels, praying for it to be over soon. Now, with the criterion-led category, you're still on your own, but you're starting at the slowest speed of 50 cc's with steering assist on. Maybe you're at the Moo Moo Meadows circuit at first, and then graduate to the next level once you medal on each previous course until you're eventually ready to unlock a larger challenge with cooler cars that help you go faster. In errorless learning, your big sibling would be there, and you'd be able to model your gameplay after their own. They'd hold down the buttons while you turn at first to teach you how to drift. The screen would indicate when to jump, and you'd get a bullet anytime you slip past maybe 5th or 6th place to start fresh in an area with less obstacles ahead of the pack. Most importantly, your sibling would be watching your behavior to ensure that by the time they nailed you with that blue shell, you're resilient enough to take it on the chin and get right back on course. Within the research community, there's been some discussion on why some choose not to adopt an errorless strategy for research behavior tasks. Some feel it'll take too many resources by way of staff time and expertise to teach animals this way. There's also lots of worry around prompt dependency, which is the idea that the animal may never become truly independent at a task, which could bias study results if humans are helping them along the way in initial phases of learning. Finally, some researchers have also argued that because macaques are contra freeloaders, maybe they enjoy figuring things out on their own and This type of teaching potentially prevents them from practicing resiliency. However, we have found that having a program rooted in applied behavior analysis is worth the resource it necessitates overall. And if we do have expertise in this area, then great trainers will develop a training plan in which prompts are faded out as soon as mastery at an approximation is obtained to prevent this sort of prompt dependency. As for the final argument, it's helpful to look at a macaque's natural history to understand their preferences on this. We do know that yes, macaques spend a great deal of time foraging, but we also know that if finding food is too difficult in one location, animals change territories to ensure availability of food resources, which they're not able to practice in captivity. Like me, I'm sure you've heard the expression that sometimes a kid just has to touch a hot stove themselves to learn the lesson to never touch it again. But I think it's always good to check in and ask ourselves, especially in this context, is it right that to learn, you need to be burned in the first place? We know from both our human and non-human primate counterparts that social learning is common, and prediction strategies are helpful in decreasing stress. And at the end of the day, the fact that animals suffer potentially life-threatening hardships in the wild does not by itself provide justification to impose it on captive research animals. With that being said, we believed it was important to set our own internal welfare bar for what constitutes good care. At Neuralink, we constantly ask ourselves, do the animals have the ability to control as many aspects of their day-to-day life as possible, including having a sense of agency and control during behavioral training sessions? Which brought us to our research question of, was it actually possible that the errorless learning approach would produce similar performance results and frustration levels as the trial and error or criterion-led training approaches at our own facility? We also manipulated their environment by designing an entirely work-from-home gameplay setup where animals could come and go as they please, completing their daily tasks while still having full agency to practice their species-typical behaviors and socially engage with other troop members. We found this method to be quite successful. When we surveyed another lab who used a combo of trial and error and criterion-led teaching strategies, we found that their trial count was comparable to our own method of errorless learning teaching. After seeing the promising results of this preliminary data, we decided to create a more specific study to measure task acquisition efficacy across these three conditions, with the hypothesis that errorless learning cohort would be the most successful and would also show the least frustration behaviors when compared to the other two groups. We were able to implement this in a research task in which the animal holds their hand on a touch sensor for a variable duration between 0.5 and 5 seconds until they felt a duration, at which point they were supposed to lift their hand to signify that vibration was felt within a 1-second latency before returning to the hold position to begin their next trial. They were to receive automatic smoothie reinforcement at each success and would be considered mastered once they could obtain 100 correct trials at an 80% or higher success rate for 3 consecutive sessions. If at any point the animal spent over 75% of the time disengaging or attempting to destroy the equipment, we considered that that animal had opted out of the study and stopped attempting to provide them opportunities to engage with the task. Total time to mastery, trial success percentage, and trials per minute were collected throughout the process. Our participants were male rhesus macaques between 6 and 14 years old who had all undergone similar previous training, participating in our gameplay studies. In the trial and error cohort, animals were only reinforced for successfully performing the behavior at mastery criteria. A trainer was not present, and animals were given the opportunity to engage for 30 minutes at a time. In the criterion-led cohort, the animals reinforced automatically for completing the foundational behaviors of lifting their hand upon feeling vibration and holding their hand on the sensor for increasing durations up to 5 seconds. Latency to lift hand and duration of hold criteria were increased as the animal reached mastery at each learning stage. Finally, the errorless learning cohort had a training plan that was individualized to them, in which a trainer used prompts, cues, and antecedent interventions to help set them up for success at each criteria. These tools and trainer involvement were decreased as the animal obtained mastery, with the end goal of the animal performing the task fully independently for at least 100 successful trials in one session. Here's a short video of the main general stages we used to teach this behavior. Prompts were done on a most to least invasive hierarchy, but we made sure that consent was obtained for any physical prompting utilized and that prediction strategies on when the animal would be touched were given. So for example, we'd say, touching, before making contact with the animal, and then would watch their behavior to make sure they continued to consent to that level of contact. If animals didn't prefer physical prompts, for example, no problem. Visual and gestural prompts were just used instead in early learning phases, as you can see in the video on the right. Cues were used to obtain stimulus control of when to hold versus when to lift the hand. We also performed behavior scans to obtain information on their latency to approach the game, the total frequency of engaging in equipment destruction, and their frequency of disengagement to measure any potential frustration. During the study, 3 out of the 4 animals in the trial and error condition met our definition for opting out of the training, as did 1 animal in the criterion-led cohort. Another animal in the criterion-led cohort never quite made it to mastery despite continuing to opt into training sessions. All 4 animals in the errorless learning condition became mastered at the task. Out of the animals that reached mastery, errorless animals became proficient on average the fastest. Unsurprisingly, the errorless learning cohort had the highest average success percent throughout their training. This makes sense, right? The entire point is to keep them highly successful. And then we also found that errorless learning animals had a significantly lower latency to begin their task than the trial and error animals did. Errorless learning animals also had minimal durations of disengagement, whereas animals in the other cohorts disengaged at higher frequencies. Animals in the trial and error, as well as the criterion-led cohorts, also spent more time attempting to destroy the gameplay equipment, likely because they found that more reinforcing and socially relevant than playing the game itself due to those low levels of success. Overall, our hypothesis was correct, with errorless learning animals showing higher task proficiency in a shorter duration, as well as fewer frustration behaviors, indicating that errorless learning was the most effective teaching strategy, as well as the most preferable from a welfare standpoint. For us, the biggest barrier to teaching animals errorlessly is still the time and expertise required to execute a complete training plan. In the future, we hope to live in a world where software accomplishes most of this work for us. In our ideal world, animals would perform tasks in naturalistic environments completely independently. We'll post updates on our blog as we continue working on this, so feel free to check that out. Our next steps are to track the maintenance of the behavior among the animals who were able to obtain mastery at further time points. We'd also like to repeat this study with a larger cohort and with alternative behaviors, and potentially even begin working with other institutions to capture more data on this as well. I'd like to extend a thank you to everyone who helped support this project, including my partner in ABA crime, Autumn Sorrells, and of course, to all of our monkey friends. Thank you so much.
Thank you, Kylie. Thank you, Kylie, for that really exciting presentation and really lovely videos that were included in there. So I'm going to open it up for questions, and I have a question from Stephen Wickens. Did you also monitor physiological signs of stress associated with the 3 different methods of learning in addition to their behavior?
We didn't monitor physiological stress for this study specifically, mostly just because the animals on this specific study didn't need their blood or anything else collected otherwise, and in an effort to just take a least invasive approach and not have them undergo things that they otherwise wouldn't, we chose not to, but it's definitely something we would be interested in monitoring in the future, especially if we opened it up to a larger cohort size.
Thank you. And then Bertha Nielsen says, given that the effortless learning takes longer, could you give us some thoughts on the cost benefit of that? Is it outweighed by the higher success rate, or what's your thought for practical implementation? Sorry.
We actually did find that the errorless learning cumulatively took the least amount of time. If you look back on that graph, the trial and error method was similar in the amount of time it took, but that was for specifically the animals that even got to that mastery point. So because 3 out of 4 of the trial and error animals did opt out completely, it was just the one animal who was represented in the graph of how long it took. So essentially, while trial and error might work for, every few individuals, obviously animals are incredibly individualistic and they all have differences, and some might just like to figure it out on themselves.
Mhm.
Consistently, the errorless learning was the most effective approach overall. Yeah.
Okay. And just a methodological question. How did you, if I understand your setup correctly, there may be a confound with the social interaction, the demonstrator effect, um, with the type of learning. Am I correct that the animal would be choosing his time of day or her time of day on when they would interact with the equipment, and then you had set times when you were doing the errorless learning because the demonstrator was there, the human
So
demonstrator.
yeah, we did have a specific 30 minutes that was the same 30 minutes for the errorless learning condition. But
Mhm.
within that, obviously, because they were in enclosures and didn't undergo any sort of restraint or restriction, they were able to leave if they didn't choose to participate. So technically, the errorless learning animals were also able to leave if they didn't choose to participate.
Okay.
But we saw very low levels of that because they were so enthusiastic about the training.
Okay. Yeah. Thank you. Um, and Hugh Golich, do you hypothesize that the behavior will take longer to extinguish if it was acquired by effortless learning?
I would hypothesize that, and yeah, I think it's one of the interesting things that we're looking to follow up on of like 3 month, 6 month, 9 month data. If you put that same task in front of animals, there might be a little bit of behavioral momentum that's needed for the errorless learning animals, just because that's what they were used to previously, right? Making sure that they were set up for success for the very beginning. But I could also see because trial and error animals and criterion led animals didn't learn the task as effectively and had lower success over time, that they might be starting from a lower point of understanding of the overall game.
Yeah.
That's typically what we see in a lot of the video games and other gameplay tasks that we do with them, even though this specific task, we didn't look at that 3 month or 6 month data. But with the gameplay, they kind of rotate in rotation, and we do find that they pick them up quite quickly when they've been taught errorlessly, even after an extended period of time off.
Oh, that's excellent. Um, and I guess that'll help with some of the cost benefit analysis of the time. Um, a question from Valerie Jonkier-Sheely. Thank you for your presentation. How do you know that when the macaques were attempting to destroy the equipment, it was rewarding?
Because they continued to do it. That's our best way of understanding that, because they continually came back over and over again to continue to attempt to destroy the equipment. There also, a lot of the consequences were followed by displays, which in
Mhm.
the macaque species is often signifying rank and social hierarchy between other members of their troop room. So oftentimes, if they would get any sort of piece of it off, they would essentially go and enact a large display, likely in an effort to show other animals, look at this fun thing I have now.
Excellent. And it sounds like if they were truly frustrated by the equipment, they could leave, right? They always had the choice of leaving.
Exactly. Yeah. They
Yeah.
have complete enclosures, and that is just one part. So that is why, ultimately, even though it could cause frustration if they were attempting to, they don't have, they can choose to not undergo that frustration. And you found that some of them did. There were, I think, 4 in total that just opted out of the session entirely and said, I'm just going to hang out on my perch.
Yeah. Thank you very much. All right. And oh, I got a few more questions in there. Um, Another one from Stephen. Did you look at rewarding the behavior less frequently in the errorless learning? And if so, did it make a difference?
We faded them out very specifically as success was maintained. Essentially, as long as they were over 80% successful at each criteria, that is when we would increase the criteria. And some of that increasing criteria was fading out the frequency of rewards. I can tell you that 2 of the animals that were a part of that project did continue their actual studies with this task, and they are currently only being rewarded at a certain rate of or ratio of like a 3-to-1. Every 3 that they complete, they'll get a reinforcement, and they're still actively contributing thousands of trials a day. So again, I think that as long as you start with the Errorless and then you fade it out incredibly methodically, they are still reinforced, even if that goes down over time.
Okay. Thank you, Kylie. It's a very interesting talk. If any of you have further questions, you'll see her email in the abstract booklet.
Thanks so much for the question.
Thank you. We're going to move on to the kind of a different format where we're doing our first short talks today. So what we're going to do is we have 5 presenters, and we're going to have each of those talks back to back. And after that, I'm going to have all of our speakers show themselves on camera, and we're going to have a panel discussion. So save your questions for each of these talks, and we will pull it together at the very end of that.
Hello, everyone, and welcome. Today, I'm going to talk to you about No More Canaries in Coal Mines, a systematic review of environmental health monitoring. My name is Dr. Megan LaFollette, and I'm Executive Director at the 3Rs Collaborative, where we did this work under our Rodent Health Monitoring Initiative. Traditionally, soil bedding sentinels are used to monitor the health of laboratory rodents, who are often housed in large, dense colonies. But with the advent of PCR technology, we can now replace these animals with environmental health monitoring. There are 2 major types of EHM: exhaust dust testing, which involves sampling dust from cage exhaust system, and sentinel-free soil bedding, which involves sampling soil bedding from colony cages. With both methods, you then use PCR testing. Now, some facilities have remained cautious in switching to EHM due to concern with the scientific evidence. And so our goal was to establish the evidence base behind environmental health monitoring with a systematic literature review. The methods are all fully detailed in an open access publication in PLOS One. But I'm going to skip to our results, which were exciting. We found that over 42 peer-reviewed publications had investigated EHM when we did this review. This is twice as many as evaluated sentinels in 2016. And ultimately, our results showed that environmental health monitoring detects pathogens more often than soiled bedding sentinels, regardless of sampling method or pathogen type or pathogen importance. In fact, they detect pathogens 20% more than soiled bedding sentinels, but there's no real difference across pathogen types. Furthermore, in head-to-head studies where environmental health monitoring did detect a pathogen, soiled bedding sentinels failed in 25% of the cases. Not only this, but this technique actually helps replace rodents, save cost, and even help people. Just in these peer-reviewed articles, almost 7,000 rodents are now being replaced annually due to this technique. 9 articles mentioned that cost savings were identified, and some even mentioned emotional benefits to their personnel due to decreased euthanasia. So all in all, there is very strong evidence to support replacing sentinels with environmental health monitoring. Across the 3Rs, operations, veterinary, and people, it's really a win-win-win-win solution. Now, if you're interested in getting started, we have a ton of resources at the Collaborative to help you switch. Just find them on our website. And with that, I want to thank all of my co-authors, all members of our initiative, and encourage you to subscribe to our newsletter for practical resources.
Primate Research Center's breeding colony in Mesa, Arizona. I'm Sarah Hart, and I developed Arizona's animal training program back in early 2023. Today I'm going to briefly discuss how positive reinforcement training has benefited our group housed pigtail macaques. Our breeding colony currently houses around 400 pigtail macaques in various group configurations, with most of our breeding groups housed in indoor-outdoor enclosures. The picture on the right shows the indoor portion of those enclosures, where the space can be divided into multiple sections that we refer to as A, B, and C enclosures, where we're able to target and station animals into the desired location, sectioning them off from the rest of their social group as needed. To manipulate a group in that way, target training our animals has been extremely beneficial in the day-to-day management of our colony, particularly with our breeder males, with this trained behavior generalized to our husbandry staff. This refinement has allowed for more efficient processes in shifting entire social groups indoors, as well as being a prerequisite for a larger trained behavior where our breeder males relocate from their home enclosure into a portable enclosure prior to routine physical exams. The shifting record on the right is an example of the form that's filled out daily to score how both breeder males are target shifting and how the rest of the social group cooperatively shifts. From this data, we're able to pinpoint animals who would benefit from additional training sessions and also look at trends of how animals shift for different staff members dependent on experience, gender, etc. Now I'm going to share a video of a trained behavior with a nursery reared infant. We rarely have animals in our nursery, but when we do, we make every attempt to reduce the amount of handling they receive. Training them for cooperative weights by targeting them to a pole centered on a scale placed in their home cage was one of the refinements made. And as a colony of animals that breed year-round, we consistently have a subset of pregnant females. In cases where the DVMs would like to monitor a pregnancy more closely, we've trained animals to present for awake ultrasounds while remaining in their social groups. The video on the left shows the behavior where the female targets to the mesh and presents her abdomen, allowing us to scan her. The ultrasound image on the right is a clip of a fetal heart rate we were able to measure as a result of cooperative ultrasound training. We've had success in generalizing this trained behavior with our veterinarians, resulting in confirmation of pregnancies, biparietal measurements to determine estimated due dates, and detection of fetal movement and fetal heart rates. And most recently, we've begun cage-side nebulizer training depicted here. We often treat animals presenting with respiratory symptoms with albuterol. Training our animals to approach and tolerate an additional nebulized dose of albuterol can potentially have a profound impact in managing their clinical symptoms. Taken together, the discussed refinements to our non-human primate training program has fostered an environment that contributes to a comprehensive approach of animal care. I'd like to thank my co-authors Jessica Toscano and Rita Belanca for their support in this work and on this presentation. I'd also like to thank the entire Arizona breeding colony staff, as all departments have played an integral role in making the training program what it is today. Thank you for your time and attention, and I'd be happy to answer any questions.
My name is Mustafa Farghal, and I'm going to talk about qualitative behavior assessment, or QBA, and how it can be used to capture the emotional states related to pain in Angus calves. First, what is QBA? QBA is a tool initially developed to assess animal welfare. It describes the animal's interaction with their environment, using terms such as calm, comfortable, relaxed, and so on. This study aims to investigate the use of QBA to evaluate acute pain-related emotional states and assess its reliability and validity. In this study, we adopted a hybrid method. In phase 1, which is the term generation, a panel watched 20 videos for castrated and sham castrated calves, and they generated a fixed term list with a short definition for each term. In phase 2, 10 trained and different observers scored 40 videos twice, 3 weeks apart, using Quadratics website. We have 3 results. The first one is the QBA reliability. We performed the principal component analysis, which yielded 5 principal components. Then we extracted the BC scores. We calculated the Kendall correlation coefficient for these scores. We found that the inter-observer reliability was higher than 0.6 in at least 3 BCs for 8 observers only. The inter-observer reliability was strong or very strong only in BC1. In the other BCs, it was moderate or weak. We performed the second principal component analysis, which yielded 4 BCs. BC1, or the emotional arousal, ranged from calm to frantic. BC2, or the mood dimension, was high loading for confident, comfortable, relaxed. BC3 or the negative mode dimension with high loading for tense, lethargic, and pain. BC4 or the attention dimension with high loading for alert and attentive. And this biplot illustrates the distribution of castrated and sham castrated calves in those dimensions. You can see how every group is gathered along. The second result is the constructive validity of KPA. We performed a generalized linear mixed effect model, and we found that there was a significant difference on emotional arousal in negative mode and positive mode dimensions between castrated and sham castrated calves, while in the attention dimensions there was no difference. The third result is the criterion validity of KPA. We calculated Spearman correlation coefficient between HBC and the pain behaviors, such as locomotion, activity, and facial expressions. We found a moderate strong correlation between those pain behaviors and the emotional arousal and the negative mode dimensions. To conclude, KPA can be used as a valid and reliable tool for assessing emotional states related to pain in calves. However, its inter-observer variability requires improvement. Thank you so much for the observers and the panelists and the funders for this study, and I'm welcoming any question.
Hello, thank you for joining. My name is Jennifer Bowman. I'm a PhD candidate in the Aquaculture Cooperative Extension Lab at UC Davis. And today I would like to discuss electroeuthanasia as a humane method for zebrafish across different developmental stages. The number of zebrafish being used annually in labs around the world is increasing rapidly, and this is likely due to the fact that zebrafish are excellent model organisms for vertebrates, including humans. However, in the United States and in many other places around the world, there are few regulations on zebrafish use as embryos and larvae, and there is little regulation regarding the end of life. And this is a considerable problem, as some of the recommended methods of euthanizing adult zebrafish, such as MS222, can take up to 30 minutes, and fish display aversive behavior while they are submerged. And this is one of the reasons why I wanted to investigate electroeuthanasia as a possible alternative. With the proper settings, electricity can render a fish insensible within 1 second of application. And in a 2022 study, electroeuthanasia was shown to be effective on zebrafish at 12 and 120 hours post-fertilization, and results showed no signs of aversive behavior. However, there was no data on the use of electroeuthanasia at other life stages, and that is what we set out to determine with this study. So for our adults and larvae, we utilized a step-down design. Our fish were randomly sorted into 3 different groups. We had our treatment group, which were fish that were placed in the stunning chamber and had an electrical current applied, and then they were monitored for survival. We also had a handling control and a non-handling control. This is the graph of the step-down results for our exposures. As you can see, we had 100% mortality with both 3 and 5 day post-fertilization larvae down to 25 volts per centimeter. However, we did see survival at 4 days post-fertilization at this voltage gradient, possibly due to the shorter exposure time. And because it's unlikely that zebrafish would be euthanized individually in a lab setting, we used our handling and our non-handling controls to run batch trials to determine if organism density would impact the effectiveness of electrical applications on mortality. And here we did see 100% mortality for all 3 developmental stages down to 25 volts per centimeter. Results from the adults showed 0 survival for all sizes of zebrafish adults following exposure to 2 volts per centimeter for the designated exposure time. We did see some survival in batch stuns at 2 volts per centimeter. This could be due to the orientation of the fish to the electrodes, but we believe that a longer exposure time or a secondary step such as submersion in an ice bath would result in a better mortality rate. For the sake of time, I cannot go into the embryo trials. I highly recommend that you check out my poster for the results on that. However, results on this study show that electricity is an immediate acting and viable alternative to traditional euthanasia methods. And I would like to extend my thanks to Dr. Bruce Draper at UC Davis for access to the lab as well as access to organisms. Thank you for your time.
Talk about research undertaken with my colleague Niamh Mahon about understanding drivers and barriers to lameness management on UK sheep farms. Lameness is a long-standing issue within the UK, being endemic and present on most farms. It is a multifactorial condition which can create challenges in management, yet by following recommended management practices, such as the 5-point plan, which you can see on the screen, lameness can be reduced to low levels. Culling, one of the 5 stages of the 5-point plan, is important for removing repeatedly lame animals who serve as infection reservoirs for other animals on the farm, or can have implications for breeding resilience or lack of, and conformation into future generations. Yet research shows that use of the 5-point plan is mixed, and it's acknowledged that culling in particular can be difficult for farmers to do. Understanding the role of animal caregivers is important, including their barriers and motivators to lameness change. This includes the priority lameness is given within culling decision making. Research also recommends the use of behavioral frameworks to identify target behaviors, such as the behavior change wheel, which you can also see up on the slide now. We look to understand farmer decision making surrounding lameness and culling more in depth using a qualitative approach. So we undertook 6 focus groups, 5 with farmers and 1 with vets. These lasted 90 minutes with questions focusing on lameness concerns, lameness management practices, as well as presenting participants with 3 different vignettes of different lame sheep, with the type of animal, so ewe-chup lamb, and cause of lameness, infection, industry, or born with poor conformation, also varying across these vignettes. All focus group transcripts were thematically analysed using a coding framework designed by us both, and in the context of the COMBI model, which, as you can see here, is the green circle at the middle of this wheel. We find, well, the 5-point plan was used, but not always as recommended. So, for example, the length of quarantine and varied, as did when culling took place. There are several context-specific challenges within this, relating to the farm business and the type and size of flock kept. Regardless of context, record keeping was essential for lameness management, particularly surrounding culling decision-making. The method of record keeping was less important than actually acting on the records themselves. Control was mentioned in relation to the wider industry. Given that farmers need to buy in stock, even if it's just breeding rams, the interconnectedness of the industry was raised as others' lameness management practices could therefore impact on your farm. So, especially if the lameness history or treatment record is not transparent when purchasing. So, thank you to my colleague, Dr. Neve Mahan, the National Sheep Association for their help with the research, and our funder, the Animal Welfare Foundation. More information can be found on our posters.
All right, I invite our poster speakers to unmic and put their cameras open. And we had a blitz there, and there's lots of questions. So I also want to say, remember that if you've not asked a question, that these posters are available asynchronously, and you can pose any questions that you want there, so that the poster presenters will be checking those and responding to those. So starting down at our first speaker, I had down here, a second, where are we? Okay. Megan, was there a difference? This is from Stephen Wickens. Was there a difference in the cost between those 2 systems of monitoring? Your results were very promising, and he's also interested in what was the appetite within the industry to move to EHA?
Yeah, so I'll answer the second part first. So here in the United States, we're seeing a lot of uptake in these techniques in replacing sentinels. Yeah, it's definitely becoming kind of the norm, and we're seeing a lot of transition here in the States and a little bit in Canada, but we're trying to help expand that to Europe and the UK and other parts of the world now. And in terms of cost, it really just depends. In general, we find that if institutions do a full cost analysis that includes taking into account the technician time and per diem of the sentinel animals, that it's usually less expensive to do EHM, but sometimes it depends on if they have not been doing PCR testing, if they've only been doing serology or simpler techniques. But we've also recently released a paper that is kind of a consensus on which pathogens institutions should be testing for. So you could run a smaller panel to also decrease costs. So,
thank you. Sarah, I had a couple of questions for you that were about training. So from Talia Lewis and from Berta Nielsen. So generally, how long does it take to train? But specifically also, how do you train the lower hierarchy macaques in group house settings?
Yeah, that's a great question. So I guess if there's a specific behavior, I do have some uh, times on how long those behaviors took. But going back to focusing on the lower ranking animals, we are able to section off the enclosures. And so that often starts with training the higher ranking animals to shift. Or training the lower ranking animals to shift into a specific area of the enclosure. I'm currently working on that now, and I have a group that I am working with the lowest ranking animal, and I had to section off all 4 of the animals into different areas to focus on that lower ranking animal. Another important thing is as long as the animal that you're working with is higher ranking than any of the others in that area, they can remain with their social group. So if I was working with the gamma, for example, as long as the other animals were lower ranking, I could focus on her and the others wouldn't interfere with her training.
Okay, thank you.
Yeah.
Mustafa, I have a question for you from Stephen Wickens. With the castration study, we know that some of the calves got pain relief. What kind of pain management were you giving to those calves? And you'll need to unmute yourself. There we are.
Okay, thank you for the question. Yes, the calves were a part of a big project about pain. We did many studies. They received the meloxicam, an
Okay,
oral dose of meloxicam as a pain therapy directly after castration.
okay.
Yeah.
Excellent. And there was also a question from Berthe that the PCA results appear to reflect the core affect model, the arousal valence dimensions. Do you think that's a coincidence?
Sorry, I didn't get the question.
Okay. In your graph, you had
Yes.
the there it is, just a second again. The PCA results looked very
Yes.
similar to the core affect model, the arousal valence dimensions. And do you think that are they perhaps your observers picking up on the arousal valence? Do you think that that's a coincidence or is that linked?
No, we think like the castrated and sham calves were uh, they have like similar level of attention, despite
Mhm.
some of them were in pain or not. Uh, if they are ashamed and have effective pain, but still they are attentive to surrounding. And maybe because of the study design, both calves, either castrated or not, were attentive to their surrounding because of the presence of other calves around them and the plants.
Okay. Okay.
That might affect the study.
Yeah. Okay. Thank you
Yeah,
very
it
much.
was one of our limitations.
Yeah. Excellent. Um, and then for Jennifer, let me just see, where did that, what barriers exist for using electro-euthanasia for zebrafish?
That is a fantastic question. One of the biggest barriers is unfortunately expenses. MS222 is fairly inexpensive to implement, whereas electrostunning requires the purchasing and maintenance of equipment. And another limitation that exists are the like perceived safety issues.
Okay.
But the equipment that we did use had a number of different safety protocols in place to ensure that the users were safe and not at risk while they were in use.
Okay. Thank you. And so for Beth, this is from Beth McKeek, and I'm sorry if I didn't say that name right, who also works in the same area as you are. So she's also working on behavioral changes, the behavior changes wheel for farm animal welfare and asked the question, how do you envision how your results might translate into behavior change by the sheep farmers?
That's a really great question. So I think for us, one of the real nice benefits of the project was that we were working with the National Sheep Association. So they've been really helpful in both sense checking some of our recommendations, but also in terms of helping with disseminations of the findings. So once we've managed to get our papers published, so there's my paper, but also Neve has a paper under review as well. We'll be working with them to kind of put some of those recommendations based on the wheel into kind of more accessible formats for sheep farmers, but also some of their advisors as well.
Okay, thank you. So I've got another question for Beth from Stephen Wickens. So how can the treatment of lameness be improved? Are there any easy wins that you think?
Good question. I think there's potentially I think that there was already some kind of identified wins identified by some of our participants, obviously with the caveat that they're a self-selecting sample. They chose to take part, so they're likely already motivated to engage in some sort of change. So in terms of thinking about some of the factors to do with farmer-vet relationships, taking advantage of those advisors who potentially see other farms, but also one of the things that cropped up as potentially influential was kind of peer-to-peer learning. So making use of farmer networks and where farmers might be or could learn from other people what has and maybe hasn't worked in different settings.
Okay, thank you. I've got another question for Jennifer. Was there any evidence of pain for euthanasia with the electrocution method?
Not that we could see. The embryo and larva trials were conducted in a closed system, so the stunning chamber itself had a lid that we could not see through for monitoring. But the adult zebrafish, we did not see any signs of pain or aversive behavior. Essentially, the current turned on and there was a quick contraction of the muscles in the body, so the fish might move around a little bit in the stunning chamber, but then they immediately lost equilibrium and then were motionless for the duration of the stun. So not that we could see.
Okay. And then there was a follow-up kind of, a couple of people asked methodological questions about the voltage. And was there an association between the voltage and the duration? Because that would maybe come into that question about the subjective experience too.
Yeah, absolutely. So we started off with pilot trials using the manufacturer recommended voltage gradient for each of the different age classes. And then we used a step up approach to determine the sort of least amount of time necessary for an effective stun. And once we'd found that the least amount of time, then we worked with the step down approach, looking at the voltage gradient. So trying to find sort of the lowest voltage gradient and lowest time that would result in an effective stun.
Okay, thank you. Coming back to Sarah, what has been the take of positive reinforcement training among your staff? Do they see benefits?
Definitely. And I think especially because the day-to-day has gotten a little bit easier for them, and just in managing our group housed animals. Husbandry has noted that the animals are cooperating a lot better for them, and because the training has become a part of their day as well as the animals, everything seems a little bit more just a part of, the day-to-day.
Okay, thank you. And we are now at 11:59, so there's lots of on my sheet of what I wanted to ask and on the board. So remember, go to those asynchronous posters, put your questions there. And I want to remind everybody that we're starting again tomorrow at 10 o'clock in British time. So thank you everybody for joining in.
Thanks, everyone. Bye.